Alright, so here we have an example that's equation work. We've got some information here. The intersection A and B is 50%, and the intersection of not A and B is 40%. Now A and B are independent events. Find the union of the two. And this kind of problem, it's important that it says that they're independent events, because that allows us to use the formula that says this intersection here, 0.5, is A times B, the multiplication of the two, as if it were you were multiplying the branches of a tree diagram. This would be the first part of the tree and the second part of the tree. Okay, it's 50%. Over here though, this is not A times B equals 40%. Okay, so we got this to work with, and you can see, well, we have A, we have B, and we have not A, and that's three things. It's too many things. If you only have two equations, you need well, you would need just two unknowns, A and B, say. So lucky for us, this part here, the not A, we can figure that out because it's what's left over off of 100%. Now, I've kind of ignored the problem here for a moment. Find this value, the union of the two, and we're going to use our equation work here. This is probability A, B, minus the intersection of the two. Okay, we already know the value of the intersection. That's 0.5. We have to figure out, though, we're going to use this information to figure out A and B. And so I'm going to come back up to this work in here, and I'm going to use these together and try to eliminate one of these variables. And there's a couple of different ways to do this. First thing I'm going to do is I'm going to replace this with something else. We don't want not A in the mix here. So if I take this formula and instead of probability of not A, let's write 100% minus probability of A. That's equivalent to not A. And now if we use this one and the other one, we're in business. So let's distribute this probability B in here, and it would read probability B minus probability A times probability B 0.4. Okay, and here, this value, that is the intersection of A and B, which is 0.5. So let's go ahead and put 0.5 in its place. It's minus. We'll add here, and then we'll figure out, well, probability B, 0.9. So from up here, this is 0.5, this is 0.9, this one's getting added and this one's getting subtracted. We have yet to figure out probability A. And if we take this 0.9, we can go back up and plug it back in. 0.9 right here, or we could probably even easier yet, let's go up to here and plug in probability B as 0.9 and figure out probability A. So I'll start that work on this side over here. Just write it again. And this is now known 0.9. 0.5 divided by 0.9, which is 0.5 repeating. We have these two values now. By doing some of our algebraic work, let's go ahead and put the last known value in here, 0.5 repeating. And let's go ahead and calculate that number here. 0.5 repeating plus 0.9 minus 0.5 is, let's see, 0.95. Now that 5 is repeating. Okay, so that is our final answer. kind of jumped around there a bit. It started with this. From one of the pieces of information given, and then this was kind of the key to unlocking this, is replacing not A with 1 minus A. And then we can solve for B, plug that into the other equation.